I first of all want to describe the kind of process that is involved in drawing a pathway. And that really is a case of assimilating the knowledge. So here we have the idea that you need to sort of get in there, read the literature, look at other pathway resources, and just accumulate information about what it is that you want to draw. It's the first step. And as I say, look at lots of different databases, then you need to sort of begin to order that information to some way. So a paper might call it P52, you might have to then work out what that represents in terms of a gene and what gene that is. Then you sort of go through this, basic drawing a primary pathway construction, adding information into them. So you can use these diagrams not just as a picture, but as actually an information resource. You can add lots of information to them, as I'll show you in a moment. And then essentially it's an iterative process. You do the primary thing, you then go back and you redraw it or you add things to it, and it's an evolving diagram that you're drawing. And what we're going to do now is just get into actually having a play around with this now and get you to start getting familiar with a new piece of software, which actually I think you will find quite useful. So yED is produced by a company called yWorks in Germany. It's a commercial piece of software, but it's free. So it's freeware, if you like. Now, it's actually, for that reason, a nice tool. And I think you will find it useful, even if you never draw a pathway in your life, for drawing diagrams for your dissertation. You might find this a nice, useful piece of way of doing this. So let's get started. So have you got you should have an icon on your desktop, or in my case here. So could you click that open, and hopefully you'll get that. New document, and you'll end up with this. So unlike before where you needed to input a format and it would display it for you, this will do that in certain formats, but this is one where you can actually create a network yourself from scratch. So you don't need to put anything in other than a few clicks. So if you click on a screen, so that's a left click on the screen, you have just created a node, okay? And if you click on again, you've created another node. If you drag one of these shapes from the left, you'll end up with a node with a different picture. So these are your palettes here, and you have shapes here that we can draw on here of different shapes. And actually they've got some quite nice things here. So we can actually even put people. And, oh God, they've got an even bigger collection of people than I remember. So you can pick your own symbol and make that, or even in computers, if you want to say that there's a computer here, we can draw that. So as I mentioned yesterday, nodes can represent anything that you want them to represent, and sometimes actually showing them as representing something close to what it is might help you understand what it is that you're actually representing, if that makes sense. So we can make an MSc of 2015 up if you want, and we can begin to draw that. Okay. So the next simple thing is that we can add edges to this. We can add relationships. So by clicking on a node and holding on that node, so left click, we can go there. So click on a node, drag an edge. If you click halfway through driving an edge, you can add a corner. Yeah, so if I want to go over here, drag, we can make an edge with a shape, okay? Now we're just going to do this randomly for now, just to make a network of interactions here. You get the idea, okay? So without actually thinking about it too hard, I've made myself a little network of some random things being joined together by random connections. So obviously the point about a network to a certain degree, and especially a small network like this, is we want to understand those relationships in a meaningful way. And the way that I've just randomly put edges between things means that I can't really understand what it is that I've drawn. So this is where layout comes in. So we had a little discussion on layout yesterday. And now what we can do is use this tool's layout algorithms to bring some order to our chaos that we've just drawn. So if we go to layout, we can try hierarchical. And we say OK. And suddenly we begin to see a little bit more about the overall structure of that diagram. We can see who has, so if this person has the most inputs, perhaps this person has the most outputs, and we're beginning to see some kind of order there, which was difficult to see before I actually used that layout algorithm. Equally, there are a range of different layout algorithms available, and to a certain degree, these layout algorithms are ways to bring order to different types of graphs and to convey information in different ways. So what we were using yesterday to lay out our graphs in biolayout was an organic, or something similar to what they're using here called organic. It's a force-directed layout algorithm, and it basically puts things into some sense based on this idea of forces between nodes. Let's see, orthogonal can be a bit weird, but we'll try it. Classic. So you can basically take that same diagram. So all of this is the same network, but we're just using different layout algorithms to make more sense of that network. And almost the point about a layout algorithm is to give you a representation that allows you to understand the relationships that you've actually seen within that network. So a lot of network science is based around how you actually take a lot of complex interactions and make them human readable, if you like, okay? It's the same net diagram, it has the same nodes, same edges, it's just a different layout, or a different way of viewing the same thing. And almost it's true that the layout that makes it most readable and understandable is the right layout for that network, if that makes sense. So the tool has, as I say, a wide variety of these different things. Some are more useful than others. So I don't particularly like circular layouts, but for some types of systems they can be better. Okay. So by using the mouse we can zoom in and out. Okay, make that go far away. So unlike a sort of piece of paper, this can be almost infinitely large. So our networks can be as big or as small as we want. I've lost it now. Where's it gone? If you lose it, you can press that and it'll bring it. So this here will frame your diagram within the screen that you're visualizing here. We have that little thing here. You can have a magnifying glass. Okay, so we can look closely at the given detail. Rolling the middle button allows you to zoom in. And of course, minus, plus, and zoom into selected area. Let me just get rid of that magnifying glass. Zoom into selected area means that I can say I just want to concentrate on that area, and it'll zoom into there. Okay. So a lot of nice navigation tools here to allow you to view your network at different levels, to zoom in, to zoom out, to draw them, to lay them out.